And we are going to get started with Network Health Check Best Practices. Again, my name is Mike Pennacchi, owner of Network Protocol Specialists, LLC. If you have any questions as we're going along, I highly encourage you to use the questions section in GoToWebinar, put those in. I'm going to be keeping an eye on those. And if there's a logical little break as we go along, I'll go ahead and stop and I will throw that in there. Otherwise, I'll answer that question. Otherwise, I will attack all of those questions at the end of the presentation. Now, if you saw my posts on LinkedIn or Twitter, I said no slides. Well, okay. There's going to be a couple of slides here at the beginning to just set the agenda of what we're going to be covering. And then once we do that, we're getting rid of the PowerPoint and we're going straight to the testers. You see those behind me? That's not a fake background. That is the testers. If you hear a buzzing in the background, that is the racks of equipment I have in here for running all this traffic through. So we're going to go through introduction, who I am, why we perform a health check. We're going to take a look at the following tools today. We're going to be using the NetAlly Etherscope NXG, the LinkRunner G2, the LinkRunner 10G, and the Test Accessory. So these are some of the tools available from NetAlly. We're going to look at how we use those tools in combination to perform a network health check. So a little bit about me. I own a company here in Seattle, Washington called Network Protocol Specialists, LLC. I've been professionally troubleshooting networks since 1995. I was doing that for a company I worked for before that, and then since 95, I've been traveling the world, teaching classes, helping people get to the root of network problems quickly. I'm an application developer, network administrator, trainer, and overall networking geek. In fact, things like all of these testers are sitting on stands that NetAlly put up on Thingiverse. And so if you have a 3D printer, you can go out to Thingiverse, search for NetAlly. But like this week, my filament got damp. It was brittle, so I put it in the oven. So my wife came in and it's kind of like, what are you doing? I said, well, I'm drying out the filament in the oven on bread proofing. So I love networking and I want to share as much of this as I can with you. So why do we do a health check of our network? Well, in the write-up for this presentation, we talked about, fire inspectors and so on. I spent 5 years on a volunteer fire department when I lived up by Yosemite. And what I found is people love firefighters. They love the person that's going to come in and save the day. But as a firefighter, if I brought in a 2.5-inch hose line, I was pumping 250 gallons per minute of water into your living room. When the fire inspector comes in, everybody hates that person because the fire inspector is looking for problems and trying to head them off before they set your house or business on fire. This is what we're doing in the presentation today, is we're taking a look at some of those things that can cause problems on your network and how we can use these tools to go in and figure out how to head those off. Where do we see issues out there with the network? So what we want to do, we want to keep our customers happy. We want to establish a baseline. What does the network look like when it's normal? And that's really important because if we don't know what normal looks like, how do we know when something's not working right? So the more time you spend with your network analysis tools, the better you'll get with those tools and the better understanding you have of your network. We want to do things like identify performance issues. Oftentimes, we can run into a situation with our network where things are getting through, but they're not getting through well. So by going in and doing a health check from time to time, we can identify, is there a place in here where we're not getting the throughput that we expect? And how do we know the throughput we expect? We measure it and find out. We're going to look at how we can document what's going on our network. All of the tests I'm going to be doing today, we will be uploading to Link Live. Toward the end of the presentation, we'll log into Link Live. Now, just for the sake of time, what I've done is I've taken all of the different tests that we're going to do, and I've generated some reports. I'll show you how to generate the reports, but I wanted to make it a little bit faster, so I already did some reports. We're going to look at how we can use this to document our network. And I know nobody likes to document, but you're going to see it is so easy as part of this testing to do the documentation at the same time. And we can use this to identify security issues in our network. So, a couple things we're going to do. We're going to do a wired network health check. Now, as I mentioned, I'm using the NetAlly Etherscope NXG and the LinkRunner 10G. So what's the difference between these two tools? What we're going to find is that the Etherscope NXG supports both wired and wireless testing, where the LinkRunner 10G is a lot like the Etherscope NXG. They're the same form factor, but it only does wired. Now, if we flip over here, we just take a quick look. Here is an Etherscope NXG. So this is going to be the tool that we're using today for going in and doing a lot of our testing. If we come over and we look at the top of that, we see that we've got a few different interfaces. I've got a gig/10 gig fiber interface. I've got a copper interface that does 10, 100, 1000, 2.55, and 10 gig. So this runs on an Android platform. We're going to be using this to do the majority of our testing. Now, one of the beautiful things about this tester is that I can remote into it. So I'm going to be VNC'd into it. It's sitting back here on the shelf behind me. So we're going to VNC into that and drive it remotely. So what are we going to look at here? We're going to do some connectivity tests. So these connectivity tests tell us a lot about what's going on with our network as far as can we get to the resources that we need to get to. Then we're going to do a throughput test. Are we getting the throughput out of our network we expect? We'll take a look at path analysis. What path do we take to get to different resources? And then we're going to wrap up the wired side with a network discovery. We're going to discover what's out there on the network, and then we're going to go in and upload that to Link Live and see how we can generate a network diagram from that. From there, we're going to move into a wireless network health check. We're going to do a connectivity test. We're going to take a look at our air quality. We're going to do an auto test. We're going to test multiple SSIDs. We'll do a throughput test. We'll do a channel analysis to take a look at what's out there on our various channels. Do we see adjacent channel overlap? This is where, for 2.4 gigahertz, we may have somebody on channels 2, 3, 4, or 5. That's bad, right? So 1, 6, and 11, that's the channels we want to see. So do we have a device sitting out there on one of these other channels that we want to move over to a channel that works better for 2.4? And we're going to take a quick look at AirMapper out here and how we can do a wireless survey. A lot to cover. We're not going to be able to, I'm not going to wander around. I'm not going to leave for an hour and do a wireless survey and come back and show you. We're going to take a look at some things we've already done in there. Now, I've mentioned Link Live a couple of times. Link Live is the cloud-based service where we can upload all of our test results. So what this does is this allows us to do the tests and upload it. And the great thing is we can have somebody at a remote site upload it and then we can see it immediately. So for instance, I'm working with a company this week where they're going over to Eastern Washington to do a wireless site survey. They will upload the survey to Link Live, and I'll immediately be able to go in and look at that survey and see, did they get it right? So when they do the first floor, we can say, hey, that looks great. Now when you do the rest of the floors, we know you're doing it correctly. In fact, by the time they drive back from Eastern Washington, we could have a report all put together and use insights to analyze that and have it all ready so that it's already done. So there's a lot of things that can be done using Link Live. We're going to take a look at how we can do that. All right, that's enough slides. Let's get over and start doing a network health check. So we're going to jump over here. Now let me go back here and make one little change. Okay, and I'm going to come into my discovery and I'm going to rerun my discovery and we're going to refresh that. We'll clear and rerun it. All right. So what we're going to do is we're going to start out by doing a connectivity test. So part of our network health check is going in and making sure that we have the connectivity we expect. So I'm remoted into two testers here. On the left, I have my Link Runner 10 gig, and that's over here. On the right, I have my Etherscope NXG. That's over here on the, well, depending on how you're looking at the screen and looking at me, it's over here on that side. And we're going to use this to do the primary tests. We're going to use this as an endpoint for some of those tests. But when we look at this screen, what you notice is that on the Link Runner 10 gig, we have discovery, we have path analysis, performance. When it comes to wired, we can do all these same things with the Link Runner 10 gig that we can do with the Etherscope NXG. But you do see that we've got our wonderful wired tools over here as well. Okay, so I'm going to come up here to auto test. And I am going to load a profile. So I'm going to come into my settings and I'm going to load. And we're going to say load profile. And we're going to load no VLAN. And I will hit load. So now what this allows me to do is come in here and create a series of tests. So I've got this plugged into a switch back here on the back bench. So we're going to drill into this. We're going to hit start. So when it comes to doing network health checks and best practices there, we find that there are certain key resources out there that we always need to be able to get to for things to work correctly. And these key resources include things like power over Ethernet, being able to establish a connection at full line rate, making sure we know where we're connected, getting a DHCP address, getting the DNS, and then finally, getting out to key resources we need to get to. So in this amount of time that we've been talking here, we have gone in and I've run a test, and what it does is it tells me that I am getting class 3 PoE, that the switch I'm connected to is advertising that it can do 10/100 gig, that I am connected to an untagged port, but tagged on that port are VLANs 10, 12, 14, 86, and 100. I'm connected to Studio Switch 2, interface gig 4. I was able to get a DHCP address in 4 milliseconds, and it tells me who gave me that address. So I can see that 10.0.11.1 gave me this address, which is exactly the device that I would expect would give it to me. If I got a 192.168.0 address, well, that could indicate that somebody brought in maybe a router from home thinking that would give them some extra ports, but instead it's giving out DHCP addresses. So here we can see our whole DHCP offer acknowledge, our total time to get our DHCP address. We're going to back out of there. DNS. Now, well, when we come down here, we're going to expand DNS right there. This tells me that I have 2 DNS servers. One of them's running on a Raspberry Pi that I have here in the office. And I went out and looked up some addresses. The other one is Comcast. And I'm seeing responses from both of these. Now, I'll tell you, one of the issues that I ran into on a troubleshooting job is they said, you know, the network's slow, people are having a hard time connecting. And we went in and ran a test like this. And what we found was that DNS server 2 wasn't responding. So I asked them, I said, so what's the deal with DNS server number 2? They said, oh, we de-implemented that about 3 months ago. I said, when did you start having the problems? About 3 months ago. So by going in periodically and just running a simple test like this, we're able to validate that key resources such as DHCP and DNS are responding. Okay? Now, if I come back here, we can see that I can get to my default router right there, NPS, Office Primary. But down here, I've got my network attached storage and I've got my email server. Now, email is really, really important to me. I want to make sure my email's working. So in this case, what we've done is we've gone out and we've checked port 993 for, I think that's SMTPS, and port 465, which is IMAPS-S. And I could have those two backwards. But that gives us the ability to go out and make sure that we can get from the Etherscope NXG all the way out to those services. So now I know I am able to get an address, I'm able to get the PoE that I need, I'm connected to the switch I expect, and I'm able to get to the resources I need to get to. All at the same time. This was uploaded to Link Live, and over here I get an email right here that shows me all of this information. So after that test got done running, I got this email back to show me that was there. Now what's really nice is I can come in here and I can add a comment, and I could put in, I could say 20AL.B01. Let's say that's the wall jack where I plugged in and did my test. Well, when I add that comment's going to be tied to that record. So if I ever want to know where that jack is connected, I can go back and search for that later in Link Live and be able to find that. And you also notice that I've got this job comment /health check. We're going to see that all of the test results that we're doing during this webcast are being put into a folder in Link Live called Health Check. So it's organizing those for me as I'm going through. So I'll get rid of my keyboard and I'll say save to test result. So now we're saving that comment in there. Now, most networks are not a single broadcast domain. In fact, what we find is that most networks, let me back out here, most networks contain multiple VLANs. So let me just show you this one real quick and then we'll keep moving forward. And that is, I'm going to load a different profile. Now, the neat thing with these profiles is that I create each one of my VLAN configurations, Wi-Fi test configurations as a single configuration, and then I can organize these as I would like into auto test groups. So here what I've done is I've organized all these into all of the VLANs I expect to have on that port back there. So when it comes to doing a network health check, one of the things I don't want to have to do in the future is chase down connectivity issues because somebody couldn't get to the VLAN they needed to get to. So by going in and running this auto test group, what I'm doing is I'm checking and validating that every one of my VLANs is working. So I'm tagging the packets and I'm getting an address on each one of these VLANs. So here we can see that my native VLAN worked correctly. Next, it's going to check VLAN 10, and it's checking different resources to ensure we can get to those targets from VLAN 10. Now, as part of setting up for my health check, what I did was I said, if I'm on VLAN 10, these are the resources I need to get to. I ran the test and ensured it was green. If it's anything other than green, I need to adjust that test so that I know that if things are good, it'll be green. So now I know VLAN 12 works. So it's going to go through, it's going to check VLAN 14. VLAN 86 goes through my AT&T hotspot. So if I lose internet during a presentation, we can switch over to that hotspot. I want to make sure that's working. And VLAN 100 gives me outside access. It gives me a path directly to the outside of my Comcast router so that I can hook up and not be even going through my router and my network infrastructure. So we see these are all working. I want to keep moving forward. So in this case, we see that our connections are working. I'm getting emails. I can tell you in this amount of time that we're running this, that all of these VLANs are working properly. We're getting our addresses, we're getting DNS, we're getting to the targets we need to get to. All right, I'm going to go ahead and stop that because I'm impatient and I want to keep moving forward here. So we are connected up and all is working well. Now, that's our connectivity. So part of my network health check is making sure I have the connectivity I expect. And that connectivity is not only on my default VLAN, but on all the VLANs that are on that VLAN trunk. Now what I'm going to do is I'm going to go back to my Etherscope NXG. I'm going to change my interface. So in this case, I'm going to unplug the copper cable. I'm going to plug in my fiber that's connected to my 10 gig switch. So now I'm connected up, and what we're going to do is we're going to come back up here to auto test. And before I can run my performance test, what I need to do is I need to connect my network port on the top of my Etherscope NXG to the network. So I'm going to load my no VLAN. Profile. And I'm going to go into this profile real quick. And I'm going to turn off PoE because, well, we're not working with voltages high enough around here to get PoE over fiber. So what we're going to do is we're going to turn that off because I don't want that to fail. It's okay. It'll just show that that test failed. But now what we're doing is we're connecting up, and we connected up at 10 gig. So this lets me know that I was able to establish a 10 gig connection. Now, one of the things that I like with this tester is I can come in here to my 10 gig connection. And what I'm going to do is I'm going to look at my receive power right here. Now this shows it's negative 3.2726 dBm. This is decibel meters. This is a measure of optical power. Now, when it comes to working with optics, like 10 gig, 1 gig, etc., we need to make sure that we're getting enough power at the far end to support a network connection. Now, for 1 gigabit Ethernet, I'm looking for something under negative 18 decibel meters. For 10 gig, I'm typically looking at something under 11 dBm. Now, the fiber we're going through, this is a fiber I got from a customer. It's a 24 fiber bundle that was broken. They broke about 75% of the fibers, pulling it out. So I took my fusion splicer, I spliced it all back together, but I want to make sure that I did an okay job. So here we see that the far end is putting out probably about the same, about 2.5 dBm, and we're getting about 3.26. So we're only seeing about 0.7 dB of loss. That's fantastic. That lets me know I'm getting a good optical signal here. So that makes me happy. So now what I'm going to do is we're going to find out, can we get full line rate 10 gig through this connection? Because that's what I expect. I've got these switches connected together via 10 gig. So I'm going to come into my performance test on my Etherscope NXG. Let's go back. We're going to go to settings, load. I'm going to load my 10 gig test. So we're going to load the 10 gig test. I'll hit load. Now, to do the 10 gig test, what I need is I need an endpoint. I can't just 10 gig out into nothing. Now, if we want to do something where we have a loop back on the other end, we could do Lambert, but here I'm testing through a number of switches. So I'm going to go over here to performance. This is on my Link Runner 10 gig. This is on the other end of the connection. It is connected at 10 gig as well. So what I'm going to do is I'm going to make this a performance peer. So this is my far end. This is my near end. Tells me over here that I'm going to talk to 10.0.11.172. So I'm going to come in here and hit start. I'm going to start my test. Okay. Oh, I'm going to start it on this end. Now I'm going to hit start. All right. So now we're doing our test. Now this is kind of interesting because on my test right here, I'm seeing that I'm getting 10% through here, or 10%, 100%, but look at this. Right here I'm seeing I'm only getting 1 gigabit per second. Well, that's interesting. Let's dig in. So it shows my throughput at 10 gig, I'm only getting 999.9 megabits per second, 1 gig. Down here, I see 1 gig. Now, if I look at my frame loss, here we see that we've lost 3.7 million frames so far. Now, up here, we haven't lost any. Now, this is kind of an interesting situation. In fact, I sent this into engineering, at NetAlly and said, hey, what's the deal here? What we discovered is my switch is sending pause frames. My switch is telling the Etherscope, back off, dude. You are overloading the uplink circuit. So let's see what we have going on. We have a 10 gig link where we're only getting 1 gig. And I know I expect 10 gig out of this link. I've tested it before. I know I can get 10 gig. And that is part of establishing a baseline. We must go in and establish that baseline and figure out what the network's capable of. So what I'm going to do is I'm going to come out here. I'm going to do a path analysis. Now, the cool thing with our path analysis here is that this supports both layer 2 and layer 3. Why? Because the Etherscope NXG went out and discovered all the bridge forwarding tables on my switches. So I'm going to put in the IP address of my link runner 10 gig, 10.0.11.172, 10.0.11.172, and I'm going to hit start. Oh, let's see. The joys of live demos. Let me rerun Discovery real quick. And this is something that we run into. If we expect that we're going to have layer 2 devices in between our 2 endpoints, and we come back and we don't get, it says no layer 2 devices found in there. Well, that's just something that I'm going to rerun my Discovery. And up here at the top, we see our Discovery. We'll give it another little bump. Now, what I expect out of this, and we could go back, I believe I have a screenshot around here somewhere, is I expect that this is going to tell me the path that we take between these 2 devices. So we're going to let our Discovery's almost finished. I know, live demos. All right. So what we've got in this situation is with our link runner 10 gig, that is connected out there through a switch. And here, let's do this. I'm just going to trace back the other direction. So this device is at 175. All right. So we're going to trace back the other way. This is network troubleshooting, right? And I'm going to say, configure this. I'm going to say trace a path to 10.0.11.175. Okay. We'll come back here. I'll hit start. There we go. Now, I got to look into why it's having more of a challenge tracing back the other direction. But what we're seeing is right here, my link runner is connected at 10 gig. It comes into the D-Link PoE switch I have over here at 10 gig, and then it goes out at 1 gig. What the heck? Why is that going out at 1 gigabit per second right there? Well, what's happened is when I set these switches up, I set up a primary link of 10 gig. I set up a backup link of 1 gig. So if the 10 gig link fails, it will go over to the backup. So any testing we would do, pinging, things like that, would never tell us that this type of problem occurred. So when it comes to doing a network health check, doing a throughput test from time to time is critical in making sure things are working the way that we expect them to. So in this case, I can see that right here, I'm coming out of this switch right down here at 1 gigabit per second. So what I'm going to do is I'm going to go fix my 10 gig link. Ooh, watch this. Before we do that, we're going to do a ping. So we're going to ping the link runner 10 gig. 10.0.11.172. We'll say OK. We'll go back. We're going to start our ping. Now what I'm curious about is when I reconnect my 10 gig connection, when spanning tree kicks in, is that going to cause a network outage? And this goes back to learning how the network looks when it's normal. So if I switch from one connection to another, what does that do to my network? So I'm going to come back here and I'm going to plug that 10 gig connection back in. Okay, so we just plugged that in. So now what we expect is the switch is going to flip back over to that 10 gig connection. So notice right there, we lost 4 frames. Okay, so those 4 frames are us switching over from that 1 gig link over to the 10 gig link. Now, if we wanted to, we could do the opposite. We could disconnect that 10 gig link and see what kind of impact that had on our network. Is our failover really working the way we expect it to? But what we're going to do is we're going to come in here, and for years, I've talked about not using the S word. When it comes to network health checks, this is important. We do not use the S word, should. If we go, well, that should fix it, and walk away, not good enough. So here we have our performance peer still running. So I'm going to come back in here. I'm going to go to performance. We're going to run that 10 gig test again. Did this really do what we expected it to? Now, look at our frames lost. If we look over at the link runner 10 gig, we are running at 100% over there of 10 gig. Here, we're getting 9, and I know it's hard to see with this cursor, but we're getting 9.9 gigabits per second through here. We are doing this with 0 frame loss. Now, I could live with a couple frames lost, just like we saw right there, 9, because we may be communicating with that network port. So a couple of frames lost are okay. In fact, if we scroll down, we've set our limit right here to 12,200 frames during this test, and we've lost 20 during one of our tests. So we're seeing we're below 1,000% packet loss. So when we come back, we can come in here, we see that our packet loss looks good. We passed our test based on the thresholds we set. So now I can come up and I can say I want to upload the link live. Actually, what I'm going to do before I upload that, I'm going to drill into this specific test. We're going to say upload graphs to link live. So not only is it going to upload the overall test results, but it's going to upload those graphs as well. So we'll say save. So I've done my throughput test. I've uploaded to link live. Now I have proof that I'm getting the throughput through my network I expect. Now there's one more throughput test I want to show you. Here we did a full line rate test. Do not do these during the middle of the day. This is the kind of network health check that we would do at night or after we installed a new system. If you try and jam 10 gigabits per second through your network during production, people will call you and they will not be happy calls. They'll be angry calls. So another throughput performance test we would do, let's load a different profile, is Voip. Voip's important to people. So I'm going to load a performance configuration I put together. This is our Voip test. We'll come back here. Now, I have a remote site network out there. What I want to do is I want to make sure that the folks at that remote site are getting good Voip connectivity back to the main site where the IP PBX is. So part of my network health check is ensuring that Voip is working properly. So what I'm going to do is, actually, let me show you real quick here. Let's take a look at this Voip setup. So here I've said my loss should not exceed 1%. Where did I get that? I talked to my VoIP vendor. My jitter should not exceed 20 milliseconds. Got that from my VoIP vendor. Latency should not exceed 100 milliseconds. Got that from my VoIP vendor. The other thing I did was in this test, I configured my DSCP bits in my IP header to 46 expedited forwarding, and I'm validating my QoS. So if my QoS bits are changed when they come back to me, test fails. So I've gotten this all set up, and what I've done is I set my data rate to 84 kilobits per second, which is about what we expect out of a single G711 voice over IP phone call. So let's run this real quick. So we're doing a VoIP test out there to that remote site. We can see what our latency is. Let's drill in and take a look at that. I see my frame loss. I see my latency. I see my data rate. So if these in the end line up with what my thresholds are, I'm going to pass. So this shows me I've seen some variation in my latency, but that's the internet. I see some variation in my jitter, but that's the internet as well. We're going through an internet connection, a VPN tunnel between two locations. But now I get a good picture of how is VoIP running over there. So doing my network health check, I've now done a throughput test on my local network. I've done a throughput test out to a remote network, and I'm running the traffic at an application rate, the same rate that my application would use. We see that, yeah, our latency has jumped up right here. But as an average, it's well below what our threshold is. So in the end, we pass. So what do? Well, I can come up here. I can say upload graphs to link live. There's my VoIP test. I'll say save to link live. So I'm taking that baseline I've established, upload it to link live. So if someone complains about voice in the future, I can go back, run the test, compare it with what my baseline was, what I knew was good because I did a network health check, and I can see that everything works out. All right, so what we're going to do is we're going to wrap up the wired piece of this by taking a look at our discovery. So I'm going to come in here, and here's my network discovery. I have discovered 134 devices on my network. I got a lot of devices out there. So in this case, I can sort by device name. And when it comes to discovery, we can do things like I can throw up a filter. I can say, you know what? I just want to see my switches. So I could come back. I could take a look at my switches out there. I could say, I just want to see the switches for, let's collapse this, the 10.0.11 network. So I could zoom into a particular subnet, see the switches there. I'm going to clear those filters. What I'm interested in right now, because I'm doing a network health check, are devices with problems. So I'm going to come in here and I'm going to zoom in on problem. I'm going to see that I've got some devices out there. I've got my Netgear 10 gig has one error. My D-Link PoE has 3 warnings. Well, what's going on there? Well, when I drill into that device, I can see right here that we've got some problems. So what I'm going to do is I'm going to click on problems. And it says that interface errors exceeded one or more, or exceeded on one or more interfaces. FCS errors, those are horrible. That's packet loss. That could be caused by bad cabling, duplex mismatch, a whole number of things. So I see that we've exceeded those errors. I can click on that and it tells me what I should be looking at, what kind of problem that could be. So now we're going to come back. We're going to take a look at our interfaces right here, and this shows me each of my interfaces. I'm going to scroll down, and actually, let's go up here. We've sorted by interfaces. We see that right here, interface Ether 9 is showing a warning. Now 25, we kind of blew 25 up trying to run 10 gig through it, right? That was our 1 gig interface. So I'm interested in this one because that's set to 100 meg. So right here, I come in, I take a look at that interface, and I look at my statistics. Now that is set to 100 meg full duplex. I'll tell you what, that bugs me because I expect gig on my network. But if I come in and start taking a look at my utilization, here I'm seeing that I've got errors showing up on that port. Errors in. These are FCS errors. So what I set up to demonstrate this, there's a duplex mismatch on this port. So what I did, I started with a discovery. I came down into which devices are having problems. I was able to get right down to those interfaces that were having problems, and now I could go in and see what's going on there. So I could go in and correct that issue. What's nice is I can click on the tools. I could say browse. It'll fire up a browser session, connect to that switch, and I could go in and start reconfiguring that switch and see what's going on there. All right. Now, I'm going to come back to my home screen here. So, before we leave Discovery, I'm going to back out to my Discovery. Let me back up again. We're going to upload that to Link Live. Okay, enough wired. Let's go over and take a look at our Wi-Fi. So now I want to come in and take a look at what's going on with my Wi-Fi network. So I go into the Wi-Fi application on here. Now, I'll tell you what, let's see. Yeah, I was going to bring up another ether scope, but what I wanted to show you before we do that, Wi-Fi connectivity. So let me open up my auto test. We're going to load up a different auto test profile. So when it comes to doing a health check on Wi-Fi, what I want to do is I want to make sure that my wireless network is working okay. So just like we can have a wired test that tests our wired connectivity, we're going to come in here and we're going to run an auto test that tests our wireless connectivity. So what this is going to do is it's going to go through and connect to each one of my SSIDs. So I've gone in, I've told it the SSID, the credentials to log into that, and what targets I need to be able to get to. So when it comes to doing a network health check, not only do we need to make sure that we have good wired connectivity, but we need to make sure we have good wireless connectivity as well. So we're starting out doing just an air quality profile, taking a look at what our air quality looks like, looking for things like interferers, things like that. That looks good. Now we're establishing a connection with each one of our different wireless access points or different SSIDs. It's going to choose the best access point to connect to. So it's going to go down through here and load those up, and we can upload these test results to Link Live as well. So this gives us the ability from a network health check standpoint to be able to go out to a specific location within our organization, run the network health check to make sure, run the connectivity test to say, from this location, we have validated that we can connect to all of the different networks that we connect to. The fact it's green tells us that we are able to connect. We can zoom into one of these here. It's going to show me what channel I connected on, what AP I connected to. Did I get an address? And could I get to the resources I needed to get to, and what speed I connected to, or connected at. Okay. So we'll go ahead and let this last one run. While that's doing that, let me just take a look at a couple of the questions here. So there was a question about what's the difference when I'm doing an auto test or a target between port 80 and the HTTP test. Port 80 only establishes a TCP connection to TCP port 80. Well, a HTTP test actually does an HTTP get to see, can we get the web page off of there? So we go further in there. Can we run path analysis without the link runner? Yes, we can. In fact, if we have time, I'll show you how we can do a path analysis all the way out to the internet using a TCP port. And for the Voip test, can we use the Reflector software installed on a remote PC? Yes, you can. So I happen to have a link runner G2 out there at that remote site. However, we could take and download the application software for doing the Reflector application software, run that on a Windows PC out at that remote site, and be able to use that as an endpoint. Okay. All right. So let's go back in here, and we connected to all of our networks. That's great. So let's go into our Wi-Fi application. So when I come into the Wi-Fi application, the first thing I'm going to look at here is what my channels look like. Now this shows me some information about utilization, about what's going on out there, retries. We're going to come up here, and I'm going to go in and start by looking at my channels. Now, when it comes to 2.4 gigahertz, I want to see devices on channels 1, 6, and 11. These are the three non-overlapping channels in 2.4. In this case, I see I've got some devices on channel 3. So I'm going to click on channel 3, and I'm going to go in and look at my SSIDs. And what this does is it shows me that I've got two networks that have APs on channel 3. We've got this Netgear 31 and ASUS. Now, ASUS is running at negative 8485. This is probably a neighbor that's running something on there. Netgear 31 is negative 48. That's pretty strong. That's actually an AP here in my office. So this tells me I need to go find Netgear 31 right here, and I need to chase that down, and I need to fix that. I need to correct that issue right there. Okay, I've got actually so here, Netgear 31, one of those is a router board. That's one of my devices. But it looks like one of my neighbors has a Netgear 31 out there as well. Boy, that could be problematic, couldn't it? They have the same SSID as I do because it's some default on the Netgear routers. So a couple things I pull out of doing my network health check here is that I've got this neighboring AP out there that's using the same SSID. So I could end up with people that are trying to connect to that SSI, that network, that AP, when I really wanted them to connect to mine. So a few things we could do here to rectify this. One is we could go in and actually we see that mine is on channel 1. So I'm okay. It's my neighbor out there on channel 3. We want to talk to our neighbor. I'll go talk to them. They kind of freak out when I show up at their houses with my tester and go, you know what? You need to change that off of that channel. Now in this case, channel 4. I don't want to see any devices out there on channel 4. So I'm going to come in here. I'm going to look at channel 4. NPS Mobile, that's my AT&T hotspot. I need to go in and see if I can change the channel on that. All right. So in this case, we could go in and we could take a look at what's happening with our channels out there. When it comes to a health check standpoint, some of the other things I'm interested in is I can take a look at APs and I could sort by channel. Well, let's see. Actually, I'm going to go back to channels, and I want to see AP count. That's how I can get there. So I can sort by that, and I'll sort right here. So right here, channel 1, I see 6 APs. So what I looked at previously was adjacent channel overlap. That's where two channels are close to each other, could be interfering with each other. Here, I've got co-channel overlap, and that's where I have 6 APs on channel 1. And I only have 3 on channel 11, 2 on channel 6. So from a network health check standpoint, what I might want to do here is move some of those APs that I have control over off of channel 1 onto channel 6 and balance that out a little bit better so I have less contention for that channel. So when it comes to a wireless network health check, some of the things I want to look at here are ensuring that I've got a good balance of APs on each of my channels. The other thing that we can see from here is interferers. So we see some Bluetooth interference. We can also go into interferers and take a look at things like microwave ovens, cameras, other things that could interfere with our wireless network. Now, we're going to finish up by doing one last thing with Wi-Fi, and that is I'm going to come into my auto test, and I'm going to connect to Netgear 77, 5G. Let me just look at a MAC address right here, 887. All right, so I've connected to my wireless network. So the last thing that we're going to do when it comes to Wi-Fi before we switch over to Link Live is we are going to come in and we're going to run a throughput test to a test accessory I have back here. So I'm going to come in and configure my test. Right here, I'm going to select the device right there. And what that is, what the test accessory is it's a little PoE powered iPerf server. And we're going to go out the Wi-Fi port. I'm going to hit OK. We're going to run this for 10 seconds. We're going to run TCP, and we want 100 megabits per second. So let's start this test real quick. So now on my wireless side, I'm doing a wireless throughput test. See what kind of wireless throughput I can get. I got to be careful because I'm probably contending with my computer trying to do this webcast. But in this case, we see that we ran our test. We've got about 2 seconds left to go. And we said that we failed our thresholds. So in this case, I only got 83 megabits per second there. Wow, nice. I got 212. So this is where doing a health check, I'm able to measure my wireless throughput. Now this could be any iPerf server. This could be a PC running iPerf 3 on the other end. All right, so we have gone in, we've done some wireless testing, we've done some wired testing. What I want to do is I want to come over here, we're going to connect into Link Live. Now, Link Live is where I've been storing all of my test results. So the first thing I'm going to do in Link Live is I'm going to click on this folder right here for Network Health Check. So what this has done is this has gone in and zoomed in on just those 31 tests that we've saved for this Network Health Check. So here we can see all of the information where we have connected to those various APs. And if I click on any one of those tests, we come over here, it tells me my data rates, my signal, my noise, my SSID, my BSSID. So I can see all of that information about that test. If I click on analysis and I say network health check, right here we have our discovery. So we have a discovery that we saved at 9:42 a.m. I'll go ahead and click on that. So from that discovery, I can come in and say, show me the topology. So what this is going to do is this is going to draw out a map of my network. So as part of my network health check, what I can do is come in here and draw out a map of my network. I can see how things are connected. So if we zoom in, we can see each of our different access points, like my studio access point, and I can see all of the devices that are connected to that particular access point. Okay, I can come over here. I can see that I've got this upstairs AP. What's connected to that? I can start taking a look at all my switches. So now, out of this network health check, I've drawn a map of what's on my network. Now, if we zoom out of here, we go back, we go to our analysis. One of the things that I can do is I can create a differential. So I can come in here, I can create a discovery difference. I can take my network as I knew it when everything was working well. I've established my baseline through my health check. I can then come in and create a discovery difference. Now with my discovery difference, it tells me how many devices are missing, how many devices are new. So what this does is this allows me to come in here and I can take a look at what the difference is between the network when I did the health check. So we see our colors in here show us, our different devices, and we can go in and start changing some of the different options. Oh, this is one where I get myself stuck. Let's see. All right. See if we can get myself out of this. There we go. Too much zooming. But we can go in and we can look at what the differences are. So we're almost at the end of our time here. So what I'd like to do is I'd like to just come over here and show you the reports. So what I did was I generated a report, and here's my network health check throughput or auto test and throughput report. So in this case, I have come in and I generated a report out of my test results. I've got my company logo in there. We can come down here. What this is going to do is show us information about our VLANs, and it's going to show us the individual test results for each of our different VLANs that we tested. I can scroll down through there. So this shows that I had connectivity that I expected to all my VLANs. So I scroll down, I can start getting into things like my throughput tests, where we can take a look at what our throughput looked like, and then we can attach those graphs that go with our throughput. So when I'm done doing this health check, I can generate reports of my network topology. I can generate reports of what I discovered on the Wi-Fi. I can generate reports on my connectivity. So to summarize, and I got a couple questions I'll answer after that. To summarize, what we find is that being able to go in and see what's out there, validate our connectivity. Can I get to all the resources I need to get to? Do I have the throughput that I expect, whether that's wired or wireless? Do I have any interfaces on my switches that are having issues? So with the Etherscope NXG, using SNMP to query all of the routers and switches and pull error stats off of those ports, I'm able to very quickly determine if any of those ports are having problems and drill in on those issues. Doing this periodically will help me become better at using the tools I have and help me understand the network I've got and quickly isolate problems that may not be readily apparent. The problem where we had a 1 gig link instead of a 10 gig link, not readily apparent unless we start going in and doing throughput tests. And the problem you're going to run into is using tools like iPerf on a PC will never be able to achieve the throughput we need to find out if we're having problems with links like that. We need hardware tools. So there was a question about, is there a better pinout for PoE for 802.3 AF or between AT? So I guess I'm thinking maybe you're talking about between 568A and 568B, and it doesn't matter. Either one of those configurations for PoE works just fine. All it is it has to do with whether you've got the orange and green pairs, what position you have those in. So when using PoE, it doesn't matter if you're using 568A or 568B. Both of those will work just fine. Got another question. Can we use the test accessory? How can we use the test accessory? We would use that as an endpoint for doing our throughput test. And that's where when we're doing Wi-Fi testing, we would use that test accessory as an endpoint for doing a iPerf test. And how can we know how many devices are connected to a specific AP? So just to show you in here, we've got this, and I'm gonna go through and address some of these things. I know that we're just 1 minute over our time. I don't want to go too much over, but if I come in here and I take a look at, let's go into my analysis files. We come in here to our Wi-Fi, and I take a look at my analysis, and this is what I've uploaded. Right here we see all of our channels. If I come over here to my APs, now I can start taking a look at my APs. I can sort by clients. So I can take a look at how many clients are connected to each one of those APs. Now how is it discovering this? Well, it's listening. The Etherscope NXG is going out and listening to the air and looking at how many people are associated with that AP. So again, as part of my network health check, if I do a wireless discovery and I upload that, I can come in here to link live and I can go in and sort by APs, and I can sort and find out how many devices are connected to each one of those. I can see what technologies are running on there. So here, this one we've got, it shows me how many BSS IDs we have. So we could go in and get an idea of what's going on with that. I can look at interferers. We see Bluetooth out there. Yesterday I saw we were getting a microwave oven out there. So when it comes to uploading these, we can start going in and taking a look at that. Now I told you that we'd look at AirMapper. Let's click on Westford in. I'll just show you this real quick. This is well outside the scope of everything that we wanted to cover in here, but here's where we can do a wireless heat map and start taking a look at what our Wi-Fi coverage looks like. All right, well, I would like to thank you for joining me today on this webcast, and and I hope that you got some good information out of here as far as things that we look for in a network health check. If you have any questions, please don't hesitate to contact NetAlly or myself. We'll make sure you get those questions answered. So that's it, and hopefully we'll see you in a future webcast.